Welcome at the Masters of the Codes channel. In today's video, I will continue on topic about monitoring of photovoltaic installations. I will tell you about the goals, the test results, and also about the issues and the solutions implemented from the time of uploading the previous video. And also I want to show you the new power meter, the eastron 630, and also how you are able to get data from that meter, how it compares with the built-in solution, so power meter from Huawei. And I will try to do that really briefly because after that video I'm planning to put also some other videos with more details. So details about overlay root file system, how I've been able to implement using that overlay root file system the reset function, the restore option function, and also about the improvements in InfluxDB queries, and also about improvements in Modbus queries, Modbus protocol, and also about verifying results of those Modbus queries. So let's start from connecting to the Raspberry Pi 4 to the access point network. So it's Solar Fusion Tech, and test password here. Okay. As usual, we will probably get the warning about network without internet connection. And now I'm able also to connect to the cockpit interface here. So let's log in here as installer user. The same password. Let's try again. Okay. So what I've added here. The first option is the timeout for the home screen. I've thought about it, and it's a simple option, so I chose to add it. So right now you can customize it so you are able to choose when the I would say screensaver or the base installation flow screen appear when you are not touching the touch screen. Let's see for the other options. And I've added the most of options I've added as the equipment tab here. So let's see. First option is installation power. So the rated power of the photovoltaic installation. And why I've added that option here, because I will show you that later in details. I had that situation when those readings from Modbus from the additional power meter eastron SDM 630 had been incorrect. So I've got the spike on the exported energy. It had been a real spike in few megawatts hours. So I've chose to verify that kind of data. So I've added that installation power and that file with ranges for each metric. So I'm able to verify if the current reading of the metrics from the Modbus is correct, because that happened even if a Modbus protocol, Modbus Python module reported that data are correct. So I've chose to additionally improve the checking, and I've added also those fields, as you can see, with yield energy offset, imported energy offset, and exported energy offset. I also added, as you can see, the same set of fields, but with initial keyword here. So you can imagine that, for example, from some reason, the cumulative register on the equipment, either on the inverter or the power meter, can't hold the values indefinitely. So there will be some time when the counter will start counting from the beginning. And in the code, I've added that check, so I'm able to detect that situation. And in that kind of situation, I'm able to add to those fields the last value from the database, and that field then is being added to the current reading, and that way I'm able to provide the consistency of the database even in the very long period of time. But there is also a situation, for example, especially for those power meters, when you can have the situation you need to replace the power meter or even use the power meter which already had been working in some other installation. So it can have some values, some counters already initialized, and you have no option to reset it on the meter. So you can use in that situation the reading from the power meter or the equipment. You can even load the current value here. So if we load the current value, we are able to put the current value from the equipment, from the hardware, and that way we are able to also provide the consistency of data in the InfluxDB. And also you can see here those checkboxes. So this is the option to save the field. So in the default configuration, when those checkboxes are not checked, you are only saving those parameters above standard parameters like inverter type, meter type, etc. And only if you need to alter the values below, you can then check the checkbox around the value you want to save. Other than that, we have also those tabs responsible for settings, for example. And here we have the option to generate settings, and then we can download such settings using the browser. And also we have the other option only available to the installer user. So option to store the current settings of the device to internal storage. And when I'm tapping to on that option, the main services on the device will be stopped, and then those settings are stored. And that option is really useful when you first install the whole device for the end user, and then there are some issues with the device. So the end user can either reset the device and restore settings, or if the user is able to log into that panel with his own credentials, of course, he's able to restore those settings without even resetting the whole device. We can also test it, but first I will also show you that other tab, device status. And on that tab, I've added those check. I've been inspired by the method it's done on the Synology NASes. So on the Synology NASes, you have that global health status. So I've done almost the same. So I have that global device status, and it's either okay or not okay, failed here. So if any of those additional checks fails, the device status should also fail. And here we have the briefly report. We can also check it on the Grafana from the device itself. And we have that option to generate the report. And then we can also download that report using phone or any other device. And that report is really helpful during troubleshooting some device issues. So it can be sent by email or the other way, and it contains some low-level system logs and other information. Let's wait for that report to be completed, and then I will show you. You can easily download that report using proper option. It of course depends on the amount of logs and other files, because right now there is tar archive which is being prepared on the device. So it's done. As you can see, we can tap on the download here. And here we need to authorize as the viewer user, and for now we have the same password. And as you can see, we are able to download that file here on the phone. It's not that big, as you can see. And I will also show you the same for device settings and generate settings option. So it will do the same, but for the settings. And you will get the link to download the tar file with the settings that time. So download, as you can see, the file is smaller, of course, than the file with logs. Let's take our Raspberry Pi, and what I will do here, I will reset the whole device. So let's unplug, and I will hold the reset button here, and I will connect it again. And you will also see that I've changed it a little. So right now, after the action like reset or restore settings is being completed, you will get some nice message on the console, and also the slight delay after it. So you know that it worked correctly. So let's see. settings restored, and let's wait for the device to boot up, and we will then try to check the device health, and I will also show you that option from the device itself. And after the reset, the access point passwords for the device had also changed. So right now it should fail on that test. So we have it on the tech playlist, and it's right now. So it's loading, and we should briefly be able to see the result. Okay, so as expected, device status failed, and it failed because the data loader service hadn't been able to load data, and it's caused by the Wi-Fi Modbus adapter connectivity failure. So as you can see, you can check it here nicely, and you know what you can expect and what you need to check and fix to restore device connectivity, to restore device to the operable status again. Okay, so let's put it aside, and let's connect again from the phone, but that time we will have to change, we will have to put the new password, as you will see. So the password right now is test 1 2 3 4 5 6 7 8. And so we need to hit reconnect, relog in again. We can log that time with the viewer user. So it's the it's not viewer here, it's the config user. The config user is the standard user with lower privileges, so that user should only be able to restore settings, of course from file, but also from the device itself, but that user is not able to tamper with built-in settings saved first by the installer user. So let's see here the device and the phone simultaneously. So you will see what happened, and I will confirm it. And yes, it will restart, and we will see that time without pressing the reset button. We should see that those settings had been restored. So it will also restore the access point network previous password, so that health check that time should pass with no issues. And of course, if we will want to reconnect from the phone, I will also need to update that password one more time. It's ready, so we can move on to that check. Okay. As you can see, everything works that time as expected. Uh, it's the most important status is of course the device status. Here, we can also tap on the uh, main playlist here, and I can show you that I've also improved a lot the queries response time, and it can be seen especially on the uh, long longer ranges. I don't know if we have no, we don't have one right now, but we can, for example, change the year. I have some random data loaded here, 5 years. So we can, for example, tap April here and to some day and jump to the next year, or we will get some 4 years here, so same amount and maybe some day. Apply, and as you can see, uh, the really long range few years had been showed here in like maybe 4 seconds. It's a really fast time, and I'm showing you that because I've been able to achieve that by improving those influx queries. So that is the thing I will also show you in the separate video in details how I've been able to achieve that. I can say really briefly that I've been able to manage it, but by using some built-in functions, built-in influx functions, instead of making joins and making calculations in join function. Also, I've improved some little things, like for example on that aggregated graph you have corrected fonts. Here I've been able to do that using JavaScript and using the observer technique to observe the changing content of the board, and that way from my panel for my snippet to for changing time here, as you can see, and that way I hadn't had to modify any Grafana boards, uh, or I hadn't had to modify any source code. So it's I think better approach, and you don't have to maintain your own Grafana source code, for example, and recompile it in case you need to update something. And the last thing I want to show here is that weather dashboard, or two weather dashboards, and I will also tell you a little bit about engines settings in details. But what I've done, I've added additional weather supplier, and here it's the weather.com. I thought that it's a really nice feature to add some additional weather supplier in case of the Google one, which is reliable but can also have some downtime, or Google can rearrange it somehow so it can stop working. I've left the Google one still here. Of course, you are able to choose both or just one in the cockpit settings easily. And also, I've used the Nginx reverse proxy for proxying here the whole content, and that way I've been able to additionally add cookies for accepting the consents from Google, etc. So you don't have any pop-ups and that kind of stuff here. So it integrates nicely. And what's more, let's get back to that weather.com. Using JavaScript, I've been able to cut some stuff and present that weather really nicely, as you can see. So you can interact it exactly as at the weather.com. Of course, because it's embedded as iframe here, with slight modifications, and to be able to pass the course restrictions, I had to use, as I said, the Nginx reverse proxy. So it's treated like my own, the same domain and the same ports and URL that from the Grafana. And also for the end, I will show you that it's configurable on the cockpit, but of course I will need to reconnect to the to the access point network and update password once again. Okay. Yeah, wrong password. 4. So let's switch and let's logging as in city later. Same password later. And you can see that on the weather widgets tab, you have those settings separated, so you can choose a language. And for the Google one, you can just type the city name. And for the weather.com, you need to type the part of the URL, and you can get that part just searching the city on the weather.com. So it's also the easy part. Now I've moved to my basement when I've connected the eastron SDM 630 power meter, and I want to show you how it's connected. So here I have all wirings for my house. On the left I have the power meter here, it's closed, the power meter from my energy supplier. So at the top here you can see input for each phase, L1, L2, L3, and the neutral wire also. I don't have the ground for the whole installation, so the ground wire is only here for the photovoltaic installation. Below I have the main fuses also. At the top you can see also the cables which are connected on the right of the main fuses box. So those cables, it's the output from my inverter, and also you can see that extension here for all 3 L wires, which is needed to use that Huawei power meter, because it works like a transformer, as you can see here. So it doesn't need to be connected on each wire. It works other way. So the eastron one power meter needs to be connected and the Huawei doesn't. So the Huawei meter is connected after the eastron meter right now, but it's just for testing purpose. So I want to be able to compare readings from the both meters. And when it's not connected, the eastron one, the Huawei is the only meter in the installation. And also I want to tell you that before I've decided to test the eastron meter in my whole house installation, I've tested it on the simple cord extension and used the light bulb as the end device. So I've connected it just like that. I've used only one phase, so L1 input and L1 output. I've connected to the L2 input, L2 output to the L3 input, and then I've connected the light bulb. So that way I've been able to just test the import situation. Then I've just turned the whole meter upside down. So that way I've been able to test the only the export situation, the export registers. But then I've thought that I would like to test both at once, but using just only one phase. So what I've done, I've connected the L1, but L1 output to the L2 output and L2 input to the L3 input, and the light bulb at the bottom. So in that scenario, I've been able to test the situation when I import 2/3 of energy and export 1/3, and then I've done the same, but I've turned the whole meter upside down and connected the same way. So in that situation, I've been able to test the other proportions. So 2/3 export and 1/3 for the import. So then I've moved to that connection, like you can see here. It's also worth mentioning that I've used 2 wires for each phase at the input. I've just hadn't proper diameter wires, so I've used 2 thinner wires here. So right now I will show you the configuration, and also you have two maybe 3 choices to connect that meter. You can connect it with only one phase, but of course it's not a very good solution because you can get just the cheaper meter for that. The second option is to connect just 3 wires, but without N wire. In that case, you need to switch the L2 to the N input, and of course the outputs. And the last option is to connect just 3 L wires and the N wire. And that N wire don't need to go through the whole meter. It just needs to be connected to that meter. So in the second scenario, I first connected just 3 L wires, but of course I hadn't been able to read the voltages between each phase and the N wire that way. I've only been able to read the voltages between L1, L2, L2, L3, L3, L1. So then I've moved to the current setup, and you are able to reconfigure the whole meter just pushing the configuration button, and you need to put the pin here, and you can also see the address for the Modbus here. So I used 2 here and 1 for the inverter, and other parameters are similar, the same as for the inverter. So transmission parameters, and they need to be the same because we are using the parallel setup. So we have the inverter and that power meter connected in parallel to that Modbus to Wi-Fi adapter. Of course, we can also use the the Modbus to USB adapter. I've already showed you that in my previous videos also. So here you have the configuration. So P4 means 4 wires, and you can also change it to, for example, P3, P1, and etc. So let's get back, and you have really simple readings here, like voltages and current, for example, on each phase, and other parameters, and also cumulative sums. You can see the import and the export here. Of course, it's the value from the starting point when I connected that meter. So let's move to the inverter. So you will see how it's connected. So that cable for the Modbus is connected right here. You can see it's here. Of course, it's only for test purpose for now. So it's connected like that. Here I have that Modbus to Wi-Fi adapter also, and it's connected in parallel with the Modbus cable for my inverter, but that inverter, as I've already told you, has a different address. Here I'm logged in at my Raspberry Pi 4 using SSH through my Wi-Fi dongle. So let's see how I'm able to retrieve data from that additional eastron 630 power meter. For showing data, I have that script, Python script with proper options, and lately I've also added some additional features, so I'm able to for example only see data, and also I'm able to alter those default configuration parameters, because those default configuration parameters configured using cockpit. So it's in data settings device. It's just settings.json file. So in that file we have different base equipment parameters, and as you can see, we have parameters like the meter, and if we want to use meter or not, it's 0 or 1 here, and of course connection type. So we are using Wi-Fi dongle right now, so it's the Wi-Fi adapter Modbus to Wi-Fi, and if we want to use that script, we can just put the S option. So that way we are not going to write anything to the influx database, but just put the parameters on the screen. And we have two different options to the next parameter. So it's meter use. So let's try U0. So in that situation, we are going to query only the inverter and the integrated power meter. So you can see all parameters that are kept in database. Usually they are collected by the proper service every 30 seconds. And at the bottom we have the parameters from the power meter, because those top parameters are from the inverter. So we have the parameters like energy productions, etc. But then at the bottom we have the power meter parameters, and as you can see, that parameter from the inverter will have greater values for the exported and the imported energy from the grid, because that meter works from the beginning, from the starting point of the installation, and that eastron meter had been added later. So right now let's put one here, and we will see the same set of parameters, but that time we can see here that we have different values from the power meter, because the eastron meter shows lower values here. Also, for that we have those parameters I've already shown you at the cockpit, and also you can see those parameters here in the configuration. So we have the offset. So if we would add the offset to those values and also subtract the initial values, and those initial values were correct for the time I first configured the whole meter, we would get the very close value to that value read by the Huawei meter. Also, you can see that the current parameters, like power meter, active power for example, that parameter is very close, because we have here, or maybe let's try again. So first from the inverter only, and then from the inverter combined with power meter. So we can see that here we have value from the power meter integrated with the inverter, and next we have the value from the our eastron meter. So in that case you can see those values are the same. Of course, it's not always the case. All those meters have some slight error margin, but those values are really close. I'm also in that good situation that I can compare both meters, because as I've showed you the connection of the eastron meter and then the integrated meter for Huawei, I have those two meters connected to my whole house installation. I hope you enjoyed that video. Also check my next videos, because in the next videos I'm going to show you in real details how overlay root file system works, how I've improved the InfluxDB queries, how I improved the Modbus communication, how I've implemented the additional checks for the registers gathered by Modbus, etc. Thank you for watching. Bye.